This is about the domain and range of a function f and its inverse, f inverse. I could not fit this into 1 minute, so that's why I have this longer video to explain the idea why. I'll go a little slower than I would in a short. Okay, so if we have the function f of x is square root of x, we know very well the domain and range, hopefully. The domain is from 0 to infinity, including 0, and the range is 0 to infinity as well, including 0 again. All right? Now, if we want f inverse, we go through the motions of swapping the y and the x. So that's what I did right here. And then we solve for y, so we just square both sides. And therefore, f inverse of x is x squared. Okay? Now, let's recall that f and f inverse, how are they related graphically? They are reflected about the line y equals x. So let's graph this square root function. I did it down here. It's this black curve over here. Okay? Now, if we reflect it about this dashed black line, which is y equals x, we reflect it, so kind of fold it over about this line, then we have this blue one right here. All right? Now, how does the graph y equals x squared actually look? It looks like this red and this blue. Ignore that it looks kind of bad, but you can imagine the parabola looks like that usually, is it not? It has this red part and this blue part as well. Hopefully you can see the colors on screen. Okay? But if we go by the reflection, we only have this blue portion. What happened to this red portion over here? It's gone. So you can clearly see why the domain, from a graphical point of view, is not from negative infinity to infinity. There's nothing on this side, on the negative x side, nothing at all. So our domain does not include that. Okay? That's one explanation. But here's a much simpler explanation. Remember the simple concept of f and f inverse. How are the inputs and outputs related? They are swapped. Hopefully you remember that simple concept. This is the concept that pervades why it's reflected about this, why you swap the y and the x when you find the inverse function, and now this as well. Domain is related to the input of f of x, the allowed values of x. X is the input, so the allowed inputs. So remember, input and output are swapped. So the inputs of f become the outputs of f inverse. So this moves over to the range. Range is related to the outputs. One more time, domain is related to the inputs of f. For f and f inverse, the input and outputs are swapped. So this is related to inputs for f, so it's related to the outputs for f inverse. The outputs are the range. Similarly, this is related to the outputs of f, so we swap it over in f inverse. It becomes the inputs. So that's why this moved to there. Well, these are the same, but you can just imagine this moved to here. So that's why the domain is not from negative infinity to infinity. It is 0 to infinity. You swapped it over. And I did not draw this here, but remember, if you watch my short, we input some a, you get some b, let's say, into our function f. You basically want to go the other way. What are all the possible outputs of f? That's the range. If you want to go the other way, there's only a certain amount of possible outputs. So that becomes the same set as the domain. So if you're trying to go the other way, it becomes the inputs, right? The range over here becomes the domain if you try to go the other way now. So hopefully this is a good visualization if you needed that as well. So that explains why this domain is not negative infinity to infinity. If you just blindly go by the function itself here without knowing that you were finding the inverse, then that would be true. But we're saying that this is the function f, its inverse is, we can model it as x squared, but we had to restrict the values of x. There's no negative values of x. Okay? And one more thing, remember, there's a quick way to check graphically if a function has an inverse. It's the horizontal line test. If it crosses the curve twice, no inverse exists. Okay? So if it's this actual full parabola with the red and the blue, for sure it crosses twice. If I just draw an imaginary horizontal line, or you can even go by what's on the grid over here. if you go by this one, crosses here and crosses there. So an inverse cannot exist. Okay, so if you want to go back from f inverse to f, that's impossible then, if you have this full domain of the parabola. It fails the horizontal line test as well. Okay, but if you don't have this red one, then it only crosses once and the inverse exists. Okay, so that's a final way to think about it. So hopefully this helps you to grasp the concept of why you swap the domain and range between f and f inverse, not just blindly doing it again.